All right. So again, welcome to the last session of the workshop. As you may remember where we left off, we are going to continue our discussion from that point only. So today what we are going to do, again, I'm going to turn off my camera because I'm going to write on the screen. So stop video. All right, so I'm going to write on the screen. So if you guys remember, we did talk about a couple of ions, right? What charges they should carry. So depending on that understanding, what we can build up is we can build up that how we can write the name of an ionic compound. Remember, we talk about two different type of compound. The first one is ionic, the second one is covalent. First of all, we are going to learn how we can name an ionic compound. Again, to remember how you can identify if it's an ionic compound or a covalent compound. Anybody remember that?
The ionic compounds are two. It would be a metal and a non-metal.
Excellent, right? If you have a metal and a non-metal, then it's an ionic compound. If it's two non-metal or more non-metal, then it is a non-covalent compound. All right, so for the ionic compound, again, let's talk about the ionic compound. In ionic compound, there are two parts. The first one, which is going to carry a positive charge. The second one, which is going to carry a negative charge. The ion that carries positive charge, what do we call that?
Cation.
Cation, excellent. And the ion that carries a negative charge, what do we call them?
Anion. Anion.
Anion, excellent, right? So when we have a cation and anion, the way we are going to name the ionic compound is going to be, first, we are going to name the cation, and then we're going to learn how to name an anion. Now let's talk about how to name a cation, or I would say the metal element of the ionic compound. For the metal element of the ionic compound, you are going to name that ion, or we can say cation, same as an element. There is nothing you are going to do. You are just going to use the same name as an element. For example, if I'm going to tell you this, NaCl, if I'm going to ask you to look at your periodic table and find out what is the name of a metal that has symbol Na. What is the name of it? Na means, right? As an element, we call it sodium. So when we name this, we don't do anything else. We just call them as a sodium. Another example is KCl. I'm going to ask you to find the K in your periodic table.
Potassium.
K is a potassium as an element. In this compound, we are just going to call K as a potassium. So I hope you guys understand. We are simply calling them as an element, right? All the cation will be named as an element. Now, if you remember, we also talk about the transition element, right? The middle section of the periodic table, in which they could carry more than one charge, right? It could be possible that they carry +2 as well as +3 charge. They may carry +1 or +2 charge. In those cases where the cation, or I would say the metal element, can possibly carry more than one charge, in that case, along with the name of an element, what we are going to do, we are going to write a Roman numeral in a parenthesis. The purpose of using the Roman numeral is to make sure or describe or explain that what actual charge this metal element or the cation is carrying in that particular formula. For example, if I'm going to write the name, I can say FeO2. I can say FeCl3. Okay. Let me just say FeO, would be easy. Okay, so in the first formula, Fe, what is the name of Fe as an element?
Iron.
Iron.
Everyone, iron, right? So we are simply going to call it as iron. Even in the second formula, we have Fe as an element, we call it as iron. So we're just going to use iron. However, because you know that Fe is a transition element, because it can carry two different charge. It could be +2 or it could be +3. In that case, we have to specify what charge Fe is carrying in the first formula and what charge it is carrying in the second formula. Now, if I'm going to ask you, find out what charge oxygen can carry. Can you find out for me? Look at the handout that I gave you. We discussed that yesterday. Look for the oxygen.
-2.
-2. I'm going to give extra like 30 seconds to everybody to figure it out, right? Oxygen can possibly carry -2 charge. It means it will always going to carry -2 charge. Yeah, everybody agree? Everybody able to find it?
Yes, Professor.
Right? So because oxygen is carrying -2 charge, when you put them together like a FeO, right? Fe is a cation, O is an anion. When they comes together, as you guys know, it form an ionic compound. So FeO is an ionic compound. And as a compound, they do not carry any charge. So the overall charge on this compound would be 0. Now, if I'm going to say the oxygen is carrying -2 charge, what possible charge Fe can have?
Positive.
Total 0. Positive what?
+2.
+2. Everybody understand that? Right? Overall, the positive charge and the negative charge should cancel out each other. That's the only way we can make an ionic compound. If we write a chemical formula for the ionic compound, the total charge of the cation and the anion must be the same, or it should cancel out each other. The total is 0. Then we can write this formula. All right, so in this case, when you know the oxygen is always going to carry -2 charge, in this case, iron is definitely going to carry +2 charge, right? To cancel out each other charge. Because you know in this formula, FeO, oxygen, like iron is carrying +2 charge, what you're gonna do instead of just writing iron, you're also going to write a parenthesis and write a Roman numeral 2. The Roman numeral represent what charge iron is carrying in that particular formula. So the name of the way we should name the cation would be iron in parenthesis Roman numeral 2. Do you follow this?
Yes.
Everyone? Any question?
The Roman numerals only apply when the metal has more than one option, right?
Yes, that's exactly right. Only for those elements which can have more than one charge. Yeah. All right. So for Fe, we have to write iron 2. Now in the second example, FeCl3. Now you know Fe can have more than one charge. What we have is Cl3. Now, if I'm going to ask you what charge Cl is going to carry, can you find out for me? Chlorine?
-1.
-1.
Always -1. Right? Everybody follow this? Cl is in group number 7A. It is going to carry -1 charge. However, we have a subscript to Cl. It means we have 3 Cl atoms in this formula. If we have 3 of them, if each Cl is going to carry -1, if we have 3 Cl, the total negative charge would be -3. Right? There are 3 Cl, Cl3. It means there are 3 of the Cl. Now, each Cl is going to carry -1 charge. It means the total negative charge will be -3. Now, if the total negative charge on the anion is -3, then what should be the positive charge?
3.
+3, right?
+3.
So in this formula, iron must be carrying +3 charge. So when we write the name of FeCl3, we must write iron in parentheses Roman numeral 3. The only time or for only metal when we write plus like the Roman numeral is when they can have more than one possible charge. We do not write those Roman numeral for sodium or potassium or aluminum or calcium or magnesium. The reason is they are always going to carry just one charge. Either it's +1 or +2 or +3. You get it?
Yep.
Yes, sir.
Right? Again, remember that, right? Even though when we say like in a transition element, most of the time they can carry more than one charge. There was an exception, which I mentioned that yesterday. Silver, they are always carrying +1 charge. Cadmium, always going to carry +2 charge. Zinc, always going to carry +2 charge. So if you have any of this metal element, you do not need to write a Roman numeral. The reason is because they are carrying only one charge, not other charge. Are we good, everybody?
Yes, sir.
Any question, confusion?
My question is, do we put the Roman numerals like for the name or if we're doing like the molecular formula or what?
All right, so what we are trying to learn right now is when the formula is given and if we have to come up with the name, that's when we do it. Okay, the formula, we are also going to practice on this kind of problem. I'm just trying to explain you the steps, right? But when the formula is given, like for example, CuO, right? When I give you this chemical formula and I'm going to ask you, can you write the name of this compound? In that case, when you're writing the name, you should write the Roman numeral, right? If it is going to carry more than one charge. In this case, Cu. Can you guys answer that? What is the name of the Cu?
Copper.
Copper.
It means copper, right? Now, can you find that out? Does copper carry more than one charge?
Yeah.
Yes, it does. It means we have to write a Roman numeral and we have to specify what charge copper is carrying in this particular chemical formula. To be able to find out, we need to look for the anion. We need to find out what charge this anion is going to carry. As anion, we have oxygen. Oxygen always carry
-2.
-2 charge.
Negative.
Excellent, right? Oxygen is always going to carry -2 charge. Do we have any subscript to that? No, we do not, right? It means we just have one of the oxygen. If we are just one of the oxygen and one oxygen is carrying -2 charge, so total charge that anion is going to have is -2. In that case, we can say the copper must be carrying what charge?
+2.
Great, right? It must carry +2 charge. So when we write the name of this compound, we should write copper in parentheses 2. Get it?
Yep.
Yeah. So what we just learned, we learned how to name a cation or a metal element of the ionic compound. Now what we are going to learn, we are going to learn how to name anion. Okay, for the naming an anion, there are more steps because there are more possible anions. As a cation, it is really simple. For anion, it is a little bit trickier, right? All we need to do is look at this handout, try to understand this and refer to this all the time. Okay, so what I'm going to do, I'm going to stop sharing this because I need to refresh this. So I'm going to stop sharing this. I'm going to close this. No, and I'm going to share it one more time to make sure that we don't have any more writing on the screen. Okay. All right, so I'm going to share the same screen one more time. So now it's clear. Okay, so for anion, so there are different possible anion. The first type of anion is called monoatomic anion. And the second one is called polyatomic anion. So let's try to understand what is monoatomic anion and what is polyatomic anion. As you can see, the word itself explain you. Mono means single. It means you have only one element as an anion. All the example that we said, right? Like NaCl. In this case, Cl is an anion. But what is Cl? Cl is just one element. Other example was CuO. In this case, O is an anion, but it is just one element by itself, right? We talk about FeCl3. What is Cl? Cl is again one element, even though there are more of Cl, but it is not attached with any other element. So in this case, we can call it as a monoatomic anion. When we say monoatomic, means it does not have any more than, it does not have, I would say, does not have anything like, I would say, how to say that? It does not have any more element. It just have one element as an anion. Okay. So if you have something like this, so what you're going to do, you are going to name it as IDE. So the suffix you are going to use is going to be IDE. For as an element, if I'm going to ask you, what is the name of a Cl as an element? How do you name it?
Chloride.
As an element, it is chlorine. Yeah. If you look at the periodic table, and if you look at the symbol Cl, and if you look at the name, Cl is called chlorine as an element. However, as an anion, as I would say, as a as a monoatomic anion, instead of chlorine,
It'll
we
be
are going,
chloride.
yeah, we're gonna replace INE
Chloride.
with IDE. So the name should be chloride. We already know how to name this cation. Again, it's just going to be sodium. So we can say sodium, and Cl is a monoatomic anion, which should be and with IDE. So the name of this compound is sodium chloride. Okay. Do you follow this? For
Yes,
O
sir.
as an, yeah, great, thanks. As a O, as an element, what do we call it? Oxygen. If we're going to use it as an anion in this case, right? If it's an anion, what we should name it as? IDE, oxide. Okay. So the name of this compound should be copper, because that's we already know, right? Cu is copper. Oxygen is carrying -2 charge, so copper must be carrying +2 charge. So we're gonna say copper in parenthesis 2 oxide. Okay, so let me just share the other screen with you to help you understand the names of this. Do you follow this, what I said? ClO.
Yes, sir.
Yeah.
Yep.
Yeah. Okay. So I'm going to stop sharing this and I'm going to share the other screen with you to help you understand this. So just give me 1 minute. All right. Close. All right. So in this case, all of these are called monoatomic anion. Okay, can I write this? This is a picture. All right. So if you see N3, right, nitrogen with a -3 charge is a nitrogen anion. What should we call it? Anybody?
Nitride.
That's right. Just give me 1 minute. I think stop sharing this. Just, all right. Sorry to attach my keypad. Yes. All right, so yes, in this case, what do we call n minus 3 as? We're gonna call it as, instead of nitrogen, we're gonna call it nitrite. What we just learned, we are always going to use IDE as a suffix, okay? For phosphorus, what we should call this?
Phosphide.
Phosphide.
Phosphide,
Phosphide.
right? So whenever we have monoatomic anion, we use IDE as suffix. For oxygen, we just learned it should be oxide. For sulfur, what should we call it?
Sulfide.
Excellent, right? Everybody get this now, yeah? IDE as a suffix. So every time when you see IDE, you should know that it is monoatomic anion. For F minus, I'm just gonna write that down here. We're gonna call it fluoride. Cl minus, what that should be?
Chloride.
Right? Br minus, bromide, and I minus, iodide. Okay, so this 7, I would say like eight of them, right? So all of this will be referred as monoatomic anion, and every time when you have monoatomic anion, we are going to use IDE as suffix. Okay, so now let me just give you a practice exercise. Can you guys, do you guys write this down, everybody? Or
One
can you guys,
second.
yeah, no problem.
Okay.
Yeah,
All set.
everybody took a note. Okay, so I'm going to stop sharing this and I'm going to share a whiteboard where I can give you a practice problem. Okay, so let's talk about this. Now I'm going to give you like maybe like 4 or 5 example in which you have to come up with the right name. Okay, we already learned how to name a cation. Even if it's transition element, we know how to name it, and we know how to name a monoatomic anion. So I'm going to give you some name. All right, so we have like 6 of the chemical formula. All I want you to do is name them. Okay, we learned all the rules. Okay, let me give you, I did not give you any transition element. Okay, so for this, I'm gonna give you like probably like 7 minutes. I'm gonna check on you after that. If you guys need more time, I'm gonna give you more time. Okay, so please refer to the periodic table that I gave you for naming. Please refer to the handout which we just referred to, right? In order to understand how you should name the anion, and if you have any cation which is from the transition element, refer to the table that I share with you to figure out what possible charge this transition element can carry. Okay, so it's 11:28, so we are going to talk about this at 11:40. All right, so you have 7 minutes to work on this. Sorry, 35. 11:35. Okay, guys, how is it going? Going well?
Yes, sir.
Okay, anybody like, do you guys need more time? Anybody? Or we can discuss in like after 1 minute.
After 1 minute.
Okay. Okay, guys. So the first one, MgO. What do you guys think?
Magnesium oxide.
Yeah, everyone, do you guys agree?
Yes, sir.
Magnesium oxide, Mg, it is not a transition element. So what we're going to do, we are just going to name as an element. Magnesium O is a anion. As an anion, it is it is monoatomic anion. So we're gonna call it magnesium oxide and with IDE. The next one is what it
Zinc sulfide.
zinc, right? Zn means zinc. Remember,
Zinc.
even though it is a, yes, that's right,
Sulfur
right?
fire.
Yes, even though this is a transition element, as we know, it does not carry more than one charge. That is the reason we do not need to write the parenthesis and the Roman numeral. As because it's an anion, we are going to call it as a sulfide, IDE. The next one is ALP.
Aluminum phosphoride.
Aluminum phosphide.
First fire.
Right? Al, we all know the name of the element is aluminum. So we're just gonna say aluminum. P is a phosphorus. As an element, it is phosphorus. But in here, we are going to refer it as an anion. If it's anion, it should end with IDE. So we're gonna call it phosphide. Of course, I understand you guys do need more practice with this, but that's what we are doing right now, right? If it's incorrect, it's okay. Now you know it is phosphide, right? The next one, what are we going to call it?
Alumide oxide.
Anyone else?
Or is it no Roman numeral? I'm not sure.
Okay, no problem. Anyone else? Al2O3. What are we going to call it? Al, again, it is an aluminum, right? So we're just going to call it aluminum. Sorry. And O is oxide. So oxide, aluminum oxide. So the reason why I take this example is when we name the ionic compound, it doesn't matter how many number of them are there. Like if it's Al2 or 3, doesn't matter. We are not going to be bothered about those numbers. 2, 3 is not going to make any difference when we name ionic compound. However, it does make a difference when we name a covalent compound, which we're going to learn later on. But at the moment, remember, if it's an ionic compound, we do not bother about the numbers. We just going to write how we going to write based on the rule that we learned. Al, we're gonna call it aluminum. Oxygen, it is just one element, right? It does not have any other element together as an anion. That's why we are just going to call it as an oxide. Yeah, very good.
Yes, sir.
Yes, sir.
Yeah. Anybody has any question? All right. Moving on to the next example, CaF2. What are we going to call it?
Calcium iodide.
Fluoride.
Fluoride, right? This is F.
Chloride.
Fluoride. Okay.
Yeah, iodide is I. This is F. So calcium, that is right,
Oh, yeah.
right? F is a fluoride. So fluorine. So it is going to call it as a fluoride. The next one, Na3P.
Sodium phosphide.
Sodium phosphide.
Excellent job, right? As I just told you, the number not going to make any differences, right? So we're just going to call Na as a sodium, just the name of an element, and P, because we know it is going to be an ion, so we are going to call it phosphide, sodium phosphide. And the last one, Cr2O3.
Chromium 3 oxide.
Oxide.
Chromium, what?
Chromium oxide.
Chromium.
Chromium 3 oxide.
Great job, right? Chromium is one of the transition element which can carry more than one charge. So yes, we are definitely going to write chromium, that is right. However, we need to specify what charge this chromium is going to carry in this chemical formula. Now, again, as we just discussed earlier, we need to find out what charge is going to carry. So we're just going to write them separately. The cation is on here, and this is going to be our anion. Now we know each oxygen is going to carry -2 charge. In this formula, we have 3 of the oxygen. It means we can write this 3 times, right? Sorry, 3 times. The total negative charge that oxygen is going to carry will be -6. Everybody agree? There are 3 oxygen,
Yes, sir.
each oxygen carrying -2 charge. So total negative charge is -6. All right. The same way we can just kind of, dissect this, or, we can break this down. There are 2 chromium. So we can write Cr and Cr 2 times. Now we have to know that the total positive charge on this chromium must be +6 in order to cancel out this -6 charge. Now, if we have +6 charge, which need to be distributed between the 2 chromium, what do you think? What each chromium should have? Right? We have +6 charge that needs to be distributed between 2 chromium
+3.
atom. So of course, we can divide this by 2 because there are 2 chromium. So the answer will be +3. So each of the chromium is going to carry +3 charge. If we just want to write this down here, so first chromium is going to carry +3 charge. Second is going to carry +3 charge. So total positive charge will be +6. And that is going to cancel out this negative charge. So yes, we can say it's going to carry +3 charge. And that's why we are going to write a Roman numeral 3 in here. And again, oxygen is just going to call it as an oxide. So chromium 3 oxide. Yeah,
Okay, sir. Got it. Thank you.
everyone?
Yep.
Yes,
Yes, sir.
yes, sir. Okay, excellent, excellent, right? So I hope this is clear to everyone. Now what we're going to talk about, we are going to talk about how we can name a polyatomic anion. So far we just talk about monoatomic anion, in which we just have one element as an anion. Now we're going to take as example in which we can have more element as an anion together. So I'm going to stop sharing this, go back to this. I'm going to start sharing this. All right, so let's talk about polyatomic anion. So remember, when we talk about polyatomic anion, it is not just one type of suffix we are going to use. We can use 3 different type of suffix. The first type of suffix we're going to use is IDE, right? The first type of suffix we are going to use is IDE. So in which case, even though it is polyatomic anion, it means more than one element joined together to form one anion. When do we use IDE as suffix? So these are the only 3 cases where we use IDE as a suffix whenever, even though there is a polyatomic anion. The first example is OH minus, which you see here. If you see OH minus as an anion, then you can call this as a hydroxide. H is hydrogen, O is oxygen. When you put them together, hydroxide, right? That's the way you can remember. OH minus means hydroxide. The same way, there is one more, which is CN minus. CN minus, when there is a carbon attached with the nitrogen and there is a negative charge, it means they both together acting as an anion. We call it as a cyanide. Cn minus is called as a cyanide. Okay, and if you have O2 minus 2, it means there are 2 of the oxygen, O2, which is carrying -2 charge. In this case, we are calling it peroxide instead of oxide, right? If you remember, we talk about this O minus 2. What do we call it? We call this oxide, right? Now, if you have one extra oxygen instead of one oxygen, let's say if you have 2 oxygen, so as an extra oxygen, we can call it as a hyper, right? Extra means we can refer it as a hyper. If it's less, then we can call it hypo. So instead of using hyper, we can just use per. So peroxide, that is called peroxide. Oops. Okay, so we can call it peroxide. So I hope you guys understand the difference. When there is O minus 2, then we call it oxide. But if you have 2 of the oxygen, which is together carrying -2 charge, we call it per, hyper. So we just use per, and then we're still going to use it, the same oxide. So peroxide. All right, do you guys follow this?
Yes.
Yes, sir.
Yes, sir.
Yeah, awesome. Now that was the first type of polyatomic anion in which we use IDE as suffix. Now there's a second type of the polyatomic anion in which we use ATE as suffix. So like a sulfate, like a phosphate, like a carbonate, right? So when we are going to use ATE as a suffix, so look at this table that we have on the screen. If you have any of this anion, we are going to call it as a ATE. The first one, in which the carbon is attached with oxygen, right? CO3, which is together carrying -2 charge. So what we call them? We call them as a carbonate. It's carbon with oxygen together as an anion called carbonate. As you see, we use ATE as suffix. The next one is NO3 minus, nitrogen with the oxygen together acting as an anion. What do we call it? Nitrate. Because of the nitrogen, we call it nitrate. Because of the carbon, we call it carbonate, right? The next one is PO4 minus 3. Because there is a phosphorus now, we're going to call it phosphate. The next one is SO4 minus 2. Because now it is sulfur, we're going to call it sulfate. Do you guys follow this? Carbonate,
Yes.
Yes,
nitrate,
sir.
phosphate, and sulfate. Remember, this time, most of the lecture class are online, right? If you have, so if it's online, this is something you can keep it handy. If it's in-person class, you do need to remember them. Okay, so depending on what kind of class you are registered for, make sure you put your effort in that direction. Okay, if it's online class, you can just keep those handy, this table handy, right? And you can refer to this during the exam or during the quizzes. If you have in-person class, when you have no access to the other resources, you do need to remember them. Okay, and if you guys need a help in remember like how to remember this, you can always reach out to me even during the semester. I'll be happy to help out you guys any possible way I can. Okay, so every anion that you see in this table will be used will have a suffix called ate. Now if you have a anion which have one less oxygen than what you see in the table, one less oxygen compared to what you have in this table, then we are going to use ite as a suffix. Instead of ate, we use ite as suffix. For example, if I'm going to give you a anion, which is going to be NO2 minus, right? If you have if you have NO2 minus, which is one less oxygen than what you have in the table, then instead of calling it nitrate, we are going to call it nitrite. So what we just did, instead of ate, we use ite as a suffix. Same way we can apply to the phosphate. Instead of PO4, if we have PO3, one less oxygen, but the same charge, then what we call this? We call it, what do we call it?
Phosphite.
Phosphite.
Right. Yeah. If you have SO3 minus 2, what do we call it?
Sulfide.
Sulfide.
Phosphide.
ITE as suffix. Okay. So as long as you can remember the table, you know all of these anion in the table are going to end with ate. If you have the table as a reference, you will be able to figure out if you have one less oxygen, and if you have one less oxygen, you're going to use ite as a suffix. So nitrite, phosphide, sulfide. Okay. For perchlorate, it is an exception. I'm going to give you more detail about perchlorate, how we're going to name if we have less number of oxygen in a minute. Okay, but you can apply this ITE rule to nitrate, phosphate, and sulfate, these three. Okay, the carbonate does not exist. All right, so there is no ITE for carbonate. It does not exist. Okay, so there is no CO2 minus 2, but there is NO2 minus, PO3 minus 3, SO3 minus 2 does exist. So far, so good?
Yeah.
Yeah,
Yes, sir.
Yes, sir.
right? Now, and the last type, right? This is the last type of the polyatomic anion, which is going to have hydrogen attached to this polyatomic anion. So if you have hydrogen attached to this, how are we going to name it, right? So for that, I do need a whiteboard. So I'm going to stop sharing this and I'm going to go back to the whiteboard. However, I can show you how you're going to name it. So let's say if you have a carbonate, right, which is, let me see, I don't have more space. Okay, I'm just going to use the whiteboard. I don't have enough space to write this. Okay, so I'm going to stop sharing this. Share a whiteboard. Okay, so at the moment, okay, let me just show you that. Okay, at the moment, what I want you to have handy with you is this, right? Can you guys please open this handout that I share with you, right? Look, keep this handout handy with you, okay? So what we are talking about, we are talking about CO3 minus 2, right? So I'm just going to write everything here. All right. I think that should have. Yes. All right. So when you have CO3 minus 2, this is the one of the anion which was in a table. So what we call them? We call it carbonate, right? Now, if we put the hydrogen in this anion, so if we put the hydrogen HCO3, because generally hydrogen is going to carry +1 charge. So let me just write this down in this sense, H plus. Now what we are doing, we are trying to put this together. H plus, we are going to add it to CO3 minus 2. So when we add it, it becomes HCO3, but the charge was +1 minus 2 would be -1, right? So when we put this together, it becomes HCO3 minus. It's that simple. +1 minus 2 equal to -1. Right? So when you put hydrogen with this anion, it becomes HCO3 minus 1. And if you have HCO3 minus 1, depending on the number of oxygen, and as you can see the hydrogen in front of it, you can call this as a hydrogen because we have hydrogen attached to this, and carbonate, hydrogen carbonate. That is the name of this anion. Why do we call it? If you look at the CO3, and if you compare the one with the table, you will see, yes, CO3 is one of the anion in the table which should end with ATE. So the name of this anion should be carbonate. However, because you have additional hydrogen with it, you are just going to call it hydrogen carbonate. Do you guys follow this?
Yes, sir.
Yes, sir.
Right? Yeah. The same example is SO4 minus 2. If you look at the table from the handout, you will see SO4 minus 2 is the one that should end with ATE. So the name of this anion should be sulfate. However, let's see if I add hydrogen to that, what is going to happen? If I'm going to add one hydrogen, it's going to look like H plus. If I'm going to add them, I'm going to say HSO4. Now, if you look at the charge, -2 plus 1 would be again -1. So the final anion going to look like HSO4 -1. And if you have that, you know that SO4, you're still going to call it sulfate. But now because you have hydrogen in front of it, you're going to call it hydrogen sulfate. Now you can add the hydrogen not just to the anion that end with ATE, you can also add this to something which end with ITE. So if I'm going to give you another example which could be kind of very similar to this, SO3 minus 2, right? If you look at the SO3 and if you compare the one with the table, you will know this is not the part of the table. It has one less oxygen. If it has one less oxygen, it should end with ITE. So it should be sulfite. Okay. Do you get it?
Yes.
Yes, sir.
Right. And
Yes,
now if
sir.
I'm going to, yeah, great. And now if I'm going to add H plus into this, what is going to become? HSO3. Again, it's going to have -1 charge. And when you have this, depending on this SO3, you can call it as a sulfite, which you already learned. If you have SO3, it's going to be called sulfite. However, you also have hydrogen with it. So you're going to call it hydrogen sulfite. That's what you have here. Do you guys follow this?
Yes.
Yes, sir.
Everyone,
Yes, sir.
right?
Yes.
Do you guys have any question, any confusion? Of course, you guys do need to refer to this. You do need more practice with this, but with the time, it will come along. Trust me. Okay. All you need to do is just practice a little bit more, review this every other day if you can. Okay. Also, I just want to point out one polyatomic cation that we didn't get chance to discuss that, right? There is only one polyatomic anion, sorry, cation that you need to be familiar with, which is NH4 plus. What do we call it? We call it ammonium. Okay, there is only one polyatomic cation. We do not have any polyatomic cation. This is only one, NH4 plus, and we call it as a ammonium. All right, so what I'm going to do now, I'm going to give you the practice exercise in which I want you to refer to this table, the table that you are looking at right now. Okay, refer to this table and try to come up with the right names. Okay, and now I'm going to give you the example in which instead of just having monoatomic anion, we are also going to have polyatomic anion. And for the polyatomic anion, you do need to refer to this table. But before I do that, I still need to explain you how we're going to name the chloride. As I told you earlier, that there is some exception. So what is the exception? So I'm going to stop sharing this. Okay, I can, yeah, I'm going to just clear this. I can just use this. All right, for chlorine, right? Remember the rules that we are talking about, it can apply to chlorine, it can apply to fluorine, it can apply to bromine, and it also can apply to iodine. It means all the halogen, all the element from group number 7A, we can apply the same rule. Like what? If I'm gonna call ClO4 minus, I can also call FO4 minus. I can also call BrO4 minus, and I can also call this as IO4 minus. The same way, if I'm going to talk about the last example, ClO minus, I can also refer that as FO minus, BrO minus, and IO minus. You understand what I mean? So we are only going to talk about the rule about the chlorine. Yeah, great, right? However, if you need to apply this rule to fluorine, bromine, or iodine, you just replace the chloro with the proper word, right? Like if it's fluorine, then we're going to call it fluoro. If it's bromine, we're going to call it bromo. If it's iodine, we're going to call it iodo. Now let's talk about ClO4 minus. So if you remember the 5-box table, right? The ClO4 minus is the one that was present in that box. According to what we just learned, ClO4 minus should be called as a chlorate, right? We call it, in this case, right? The CO3 was a part of the table, we call it carbonate. SO4 minus 2 was a part of the table, we call it sulfate. PO4 minus 3 was a part of the table, we call it phosphate. NO3 minus was a part of the table, we call it nitrate. According to those rule, we're supposed to call ClO4 minus as a chlorate. However, the exception was, instead of calling it chlorate, we're gonna call it perchlorate, right? This is the extra prefix we are going to use for this halogen. Okay, why do we use per? Again, per represent one extra oxygen. So now if we come up with the one less oxygen, instead of ClO4, if we come up with a ClO3 minus, what should be the name of this compound then? Or what should be the name of this anion? We are first going to get rid of this prefix, because now it's not an extra oxygen. So now this anion is going to be actually called as a chlorate. Now, even if you have one less oxygen, right? What we just talked about earlier, from A to E, if you have one less oxygen, then it should end with ite. So instead of chloride, we are going to call this one as a chloride. One less oxygen become ite. Now, what happen if we have even one more less oxygen? So we do not learn any other suffix than ate and ite. It means what we're going to do, we are now going to move back to the prefix. Because we have one less oxygen, we're gonna call it hypo. We're gonna use hypo, and we are going to use the same name of this anion, chloride, hypochlorite. So as you can see, for all the halogen, there are 4 possible anion. Which are they? Either it could have 4 oxygen or 3 oxygen or 2 oxygen or 1 oxygen. In case if they have 4 oxygen, we're gonna call it perchlorate. If we have 1 less, it means 3, we're gonna get rid of the per. So now we're just going to call it chlorate. Now if we have 1 less, which is 2, as we just learned about the rule from ate, if we have 1 less oxygen, we're gonna call it ite. So now we can call it chloride. Now even if we have 1 further less oxygen, which is just 1 oxygen, we don't have any more suffix to use, so we're gonna go back to the prefix and we're gonna call it hypo and just use the same name, chloride. Yeah. So the first
Okay,
one and the
sir.
last one, we use prefix. For the second and the third one, we use, or we change, I would say, we change the suffix. Do you guys understand this?
Yes, sir.
Yes, sir.
Okay. Remember, like with practice, it will come. Okay. All you need to do is just need to practice on this. I explain you in the easiest way that you can remember this. Okay. If you need more help how to remember this five box table, I can definitely explain you that. Okay. Do you want me to explain you that, or you're good? Okay. So in case if you need help, you can reach out to me later on. I'll be happy to explain you that. Okay. But at the moment, all we're going to do is keep this table handy with you, refer to this table, and try to come up with the right name where I'm going to give you the practice exercise. Okay. Are we good?
Yes,
Yep.
sir.
Yes, sir.
Right. So what I'm going to do, I'm going to stop sharing this, but you should have this table handy with you. Okay. So stop sharing this, and I'm going to give you the practice problem now. So clear. All right. So Okay, so I have given you 8 practice problem. I do believe that you guys do need more time to solve this. So probably I'm gonna give you like 12 minutes at the moment. Then I'm gonna check back on you, right? If you guys need more time, I'm gonna give you more time. All right. So for now, I'm gonna give you 12 minutes. So it will be 12:22. Okay, so I'm gonna check back on you at 12:22. Please refer to the table. Remember, the number is not going to make any difference when we're going to name as an ionic compound. All you gotta do is remember how to name the cation and anion.
That is FeCO3.
FeCO3, that's right.
Professor, is the first one NaMO or is NaNO?
It is NaNO, my N, sorry. It's the N.
Thank you.
Professor, I have a question for the second one. It's MgGO3.
No, it is MgSO3.
Okay, I got it.
Okay, so I would like everybody to focus on this. I'm just gonna say it out loud for everyone, every example. The first one is NaNO3. The second one is MgSO3. The third one is AlPO4. The fourth one is Cu3PO3. The other one on the right side, the first one, FeCO3. Second one, KHSO4. The next one, Zn in parenthesis, NO3 parenthesis over number 2. The last one, Cr, now in the parenthesis, IO2 parenthesis over number 2.
Thank you, Professor.
Yeah, no problem. Okay, guys, how is it going?
Okay, Professor.
All of you guys are done? Yes?
I think so.
Yeah.
Okay, so let's discuss this. Yes, question?
No question.
Okay, so let's talk about this, right? Let's talk about the first example, NaNO3. What do you guys think? What should be the name of this compound?
Sodium.
Nitrate?
Sodium nitrate.
That is right? So the way I'm gonna help you to understand is, whenever you have this such kind of chemical formula, first thing you need to do is identify all the cations, right? Until now you did not have to do this. Why? Because there was only monoatomic cation and monoatomic anion we talked about. Now because we have polyatomic anion, we're just going to highlight. You don't have to highlight them, but just to understand this better in the beginning, you can just highlight them and you can identify, yes, this is all the metal element, and as a metal we know we are just going to call it as an element. So the name of Na is still sodium. Now let's focus on the anion portion of it, right? NO3. Now for NO3, you can refer to the table, right? The 5-box table that I show you in the handout, or you can just look at the, the list of all the anions that we have in one of the table, right? Let's say if you're looking at the 5-box table, you know that NO3 is part of that 5-box table. And if we also remember all of the ion in that 5-box table supposed to end with ATE. So yes, NO3 is supposed to end with ATE. And this is nitrogen and oxygen together, so nitrate. All right, now just in case, if let's say if you have NO2, right, NaNO2, for example, you will find out NO2 is not the part of that 5-box table. If it's not part of the table means what? The table has NO3, we have NO2, one less oxygen. It means instead of calling nitrate, sodium, we're gonna call it nitrite, sodium nitrite. Everybody understand this?
Yes.
Yes, sir.
Yeah,
Yes, sir.
excellent. Let's move on to the next example, MgSO3. What should be the
Magnesium
name?
sulfite?
Magnesium sulfide.
Sulfide. Everybody agree?
Yes, sir.
Right? Again, I generally like to refer to that 5-box table because that's how you can remember all the names of an anion. The last table that we show, which has the list of all the anion, it is not that helpful to remember, right? So for if you want to remember them, I prefer you to use the 5-box table, right? Again, if you look at the 5-box table, we already know this is Mg, so it's just going to be magnesium. But if you look at the 5-box table, SO3 is not a part of it. SO4 is a part of it. So if we have one less oxygen in this case, we are going to call it sulfide, ITE. One less oxygen supposed to end with ITE. So magnesium sulfide. Everybody agree? Any question, confusion? No? Okay, let's move on to the next one. AlPO4. What should be the name?
Copper 2 phosphate.
No, Al, we are talking about the
Is the
third.
aluminum phosphite?
Oh, aluminum phosphide.
Are you going to call it for ITE or ATE?
Isn't it
ITE?
phosphate?
Yes. Can you look at the
ATE.
5-box table? Yeah. Look at the 5-box table.
Phosphate.
PO4, right? PO4 is a
Phos-
part of the table. It means it's supposed to end with ATE.
Yeah.
Okay, so it should be so aluminum phosphate, ATE. All right. Everybody agree? And okay, Moving on to the fourth one, CO3PO3.
Copper 2 phosphate.
Copper what?
2
I got copper
um,
1 phosphite.
phosphate. This
Okay,
is Roman numerals 2.
Roman numeral 2. The other students say Roman numeral 1. And any other students? Yeah.
I said copper phosphate, phosphite.
Would you like to use a Roman numeral or no Roman numeral?
Roman numeral 2.
Two.
I can't, yeah.
2.
Two. Okay, so let's find out, right? I know that I gave you one of the tricky one, so that's okay. Let's talk about this. Okay, so I'm just gonna separate them out. Okay, if you don't know what Roman numeral to use, I would suggest you to just break this molecule down like this: Cu3PO3. Right? What I did, I just break down as a cation and anion. Now we know what should be the charge on PO3, right? What should be charge on PO3?
3 negative.
-3. If you look at the table again, the 5-box table, you will see that it was PO4 -3. One less oxygen, it should be PO3 -3. We do not change any charges, right? We just change or reduce the number of oxygen, but the charge remains same. So in this case, PO3 should be carrying -3 charge. Now we know there are 3 charge, right? Oh, okay, my mistake, guys. I didn't think about that. All right. Okay, then, okay, let me just correct this. It should be, I think it should be fine. Yeah, let's just continue with this. Right, so it means what is the total negative charge? The total negative charge we have on this anion is -3. Everybody agree?
Yes,
Right.
sir.
Yes, sir.
Now, how many Cu we have? We have 3 of the Cu. So what we can simply do, we can just simply write them 3 times, right? We know that the total positive charge must be equal to +3 so that we can cancel out the negative charge. Now, let's say if we have total of +3 charge and we have 3 of the Cu, what charge each of this Cu should carry? Must be +1. Do you agree?
Yes.
Yes, sir.
Yes, sir.
It means each of the Cu is going to carry +1 charge. That's why you can say copper 1. And now what should be the name of the PO3?
Phosphite.
Fight, not
Phosphite.
ATE, right? ITE. As we just see in above, right? It was PO4. Now it is PO3. One less oxygen. It should be ITE. Copper 1 phosphide. So the way you can identify the charge is find out the total negative charge. If that's the total negative charge, it means the total positive charge must be the same. It must be +3. Now you can just divide the total positive charge with this subscript number that you have. In this case, we have 3. So 3 divided by 3 will be 1. It means each of this copper must be carrying +1 charge. Okay, so there are different ways to do it. If you just want to write down all of them individually, you can do that to find out the charge. If you don't want to do it, then you can just find out the total negative charge. Depending on that, you can find out the total positive charge and divide this total positive charge with this subscript number that you have. If it's 3, if it's 2, whatever it is, just find that out, cancel this, right? Do the math. It is going to be 1. In this case, copper is carrying +1 charge. Anybody has any question? All right. The next one, FeCO3. What should be the name of this compound?
Furious carbonate.
Can you say it again?
Furious carbonate.
Iron carbonate.
Iron carbonate.
Iron carbonate, iron carbonate. All right, now if I just help you to remember this again, iron, what is iron? Is it transition element? Does it carry more than one charge?
Yes.
Yes, it does, right? So you just need to keep an eye out and look for the transition element. In this case, iron is a transition element which can carry more than one charge. What does it mean? It means we need to specify what charge iron is carrying. So in this case, we can say definitely iron, that is right. However, we do need to write some number in a Roman numeral. In order to solve this, again, we are going to do the same as we just did. I'm gonna write them separately, Fe and CO3. Now, if I'm gonna ask you what charge is CO3 carrying, can you help me identify this? What should be the charge on CO3?
-1.
+1.
This is anion, right? CO3 is anion, so it must be carrying negative charge. My question would be, it will be -1, -2, -3. What do you guys think? Look at the
It's
five box,
-1.
right?
-3.
-3,
-1.
-1.
Negative
Oh, I'm
1.
sorry, it's -2.
Positive.
It's -2. Yeah.
Yes, right? It's a -2, right? So all you have to do is, again, as I told you, you just need to keep that 5-box table handy with you, okay?
Yeah.
So if you keep that, you will know that the total negative charge on this CO3 will be -2. We do not have any more number of Fe, so the total positive charge must be +2. Again, as I just told you, we do not have any subscript, so there is no need to divide this number, right? It means this Fe must be carrying +2 charge. In that case, I'm gonna write a Roman numeral 2. So iron 2, and what should we name as a CO3 as an anion? CO3, what do we call it?
Carbonate.
Carbonate, right? Again, this is the part of the table, 5-box table, so it should end with ATE. So iron 2 carbonate. As I just told you, if you stick to the rules, right? If you just look at the table, if you just look at identify the transition element, then this is really, really easy. All you guys need is more practice, right? And just try to remember few of the transition element that, okay, this could be the transition element, and identify them. If you identify them, then it is easy. The next one is a little bit of challenging. Let's see if you know the answer. KHSO4. What should we
Is
name
it
this?
potassium hydrogen
Potassium
sulfate?
Potassium bisulfate.
Potassium bisulfate.
Okay, so
Bis-
yeah, you can call it bisulfate. However, of course, you can ask your lecturer professor that how he or she want to call it. In general, in this general chemistry course, or even if it's foundation of chemistry course, we generally refer as hydrogen sulfate. Okay, because bi is like a common name. We generally stick to the rules in which we just call this as a hydrogen sulfate. If you call it bisulfate, you do not, like, it's not incorrect, but generally I do like to prefer to as hydrogen sulfate, and most other professor does that way as well. So yes, you can say K is called potassium. Again, this is not a transition element, so we don't need to write any Roman numeral. HSO4, so SO4 was a part of the table, so we're gonna call it sulfate. However, because it also has hydrogen, we're gonna call it hydrogen sulfate. So potassium hydrogen sulfate, sorry. Okay. Again, SO4 was a part of the table, so it should end with ATE. The next one, ZN in parenthesis NO3 2.
Zinc nitrate.
Anyone else? That is right. Okay, zinc, even though it is a transition element, it does not carry more than one charge. It means there is no need to write a Roman numeral with this. So the name would be zinc. And nitrate, NO3, right? It was a part of the 5-box table. So we're gonna call it nitrate, zinc nitrate, and with ATE. Do you guys understand this?
Yes.
Yeah, awesome. And the last example, Cr in parenthesis IO2, parenthesis over, number 2.
Anhydrous
Sorry,
chromium, anhydrous chromium 2 iodide. I
chromium.
don't know.
I
That's okay.
agree. Chromium 2 iodide.
Chromium
It-
2
Iodide.
iodide, right? So I think I need more space to explain this. So I'm just gonna clear the screen and gonna rewrite this. Okay, CrIO2 parenthesis 2. So in this case, we know this is going to be our cation. This is chromium. Once you know it is a chromium, we also figured that out that this is a transition element which actually carry more than one charge. So now what we need to do, we need to identify them. So what is the anion here? IO2 is an anion, right? What you have in the parenthesis here, this is our anion. Now, if I'm going to ask you to find out the charge on this IO2, what is the charge on IO2?
I got -1, but don't quote me.
No, that's right. That's right. Yes, it is -1. However, how many IO2 do we have in this formula? We have 2 of them. It means we're going to write them 2 times. The total negative charge we have in this formula would be -2, right? Just in case if somebody doesn't able to figure this out, ClO4 minus, ClO3 minus, ClO2 minus, doesn't matter what you have, the charge remains same. What all we have to do is replace Cl with I in this case. So IO4 minus, IO3 minus, IO2 minus, and IO minus. So if you look at this, the one that we have is IO2 minus, right? Now we know that each of this is going to carry -1 charge. What do we have? In this example, we have 2 of those anion, right? 2 of that anion, IO2 parenthesis over 2 times. It means we have 2 of this anion. So each of them is carrying -1 charge. What does it mean? It means the total negative charge is -2. Right now, what does all it also mean? It also means that the total positive charge must be +2. Now look at the cation and look at the subscript. Do we have any subscript to the chromium? No, we do not. It means the positive charge that is going to be the positive charge that chromium is going to carry is going to be +2. Right? Do you guys follow this?
Yes, sir.
Yes, sir.
Everyone? Because we do not have any subscript, we don't need to divide this number, right? The total positive charge. So this chromium is carrying +2 charge. And we know this anion, what do we call this? This is going to be called hyper, it means per ATE. Then we get rid of the per and we just call it ATE. Then we call it ITE, and then we call it hypo ITE, right? Depending on what halogen we have, we use chlorate, right? Chloro or iodo or fluoro or bromo. In this case, we are referring to iodo. So it should be iodide. So this is the right name. Chromium 2 iodide. Do you guys understand this?
Yes.
Yes, sir.
Everyone, yeah,
Yes, sir.
great. So with this, we actually conquering then how to name a ionic compound. Now, quickly, we are going to talk about how to name a covalent or a molecular compound. All right. How to name them? It is really, really easy. This is the one that we have more rules and more diversification. When we're going to name a molecular or covalent compound, it looks really, really easy. Let me just stop sharing this. I'm going to share the rules that we have here. All right. Again, I just want you to remember this. When we talk about the molecular compound or a covalent compound, remember it is composed of two or more non-metal, right? So when you see only the non-metal in the formula, you will be able to say that this is a molecular or a covalent compound. Now, how to name that compound, right? If you want to name that, that is going, let's say, for example, CO2. We already talked about this, right? If I'm going to give you this example, CO2, what you see carbon and oxygen. Both of them are non-metal, so you know this is a molecular compound. In this case, if you have to name it for the first element in the formula, you're just going to name it as an element, right? So carbon is just, we are just going to call it carbon. For the second one, right, when you have the second element, you are always going to use IDE as suffix. There is no other suffix you need to remember. For covalent compound, it is always going to be IDE as suffix. What second element do we have here? Oxygen. So we're gonna call it, we're gonna call it oxide. All right. However, as I told you, for ionic compound, you do not bother about the number. And for molecular compound, you always write a number, right? It depending on the number, you use the prefix. Because there are two of the oxygen, we're gonna call it dioxide. So the name of this compound will be carbon dioxide. It's not just oxide. Now it is dioxide. What does it mean? It means for every element, when you have more than, like if you have more than one element, you have to write mono, di, tri, tetra. For example, if you have one of it, you always going to use mono. If you have two, you're going to use di. If you have three, you're going to use tri. If you have four, you're going to use tetra. You have five, penta, six, hexa, seven, hepta, eight, octa, nine, nona, and 10 deca. All right. But there is only one thing you need to remember for the how to name the first element. For the first element, if you have two or more, right? Oops, my mistake. All right. So for the first element, if you just have one of the atom present, in this case like CO2, where you have just one of this carbon, then you do not need to use this Greek prefixes like mono, di, tri, tetra. You do not use it for the first element if you just have one of it. But for the first element, if you have more than one, let's say if you have two of them or three of them or four of them, then you must use this Greek prefix like di, tri, tetra, penta. Okay, so for the first element, the way we're going to name is, if you just have one, you don't need to use any prefix. But if you have two, three, or so on, you always use prefix. For the second element, you always use IDE, that is right. But in terms of the prefix, even if you have one of it, you're gonna use mono. If you have two of it, you're gonna use it di. If you have three of this, you have used it tri. So no matter if you have one or more, you always use prefix for the second element. while for the first element, you only use prefix if there are two or more. You get it?
So if it's less than one, it's carbon oxide.
Yes, if we're gonna talk about this, right? I'm gonna talk about the example. If we have less, if it's just one of it, CO. For the first element, we're just going to call it carbon. But for the second element, even if it's one, we have to use prefix monoxide. So carbon monoxide is the name. So as I just told you, for the first element, if you have just one atom, you do not use the Greek prefix. But if you have two or more, then you have to use the prefix. For the for the second element, no matter how many of them you have, you always have to use prefix, and the suffix is always IDE. Do you get it?
What if it's just CO? That's what I was asking. CO.
Yeah, I just show you the name, no? Carbon monoxide is the name of CO,
Okay, got it.
right? For carbon, because it's just one of it, we are not using prefix. We are just going to name it as an element. For oxygen, it is a second element. Even though it is one of it, we have to use the prefix and you have to use IDE as suffix. So we monoxide is going to be the name of the second element, monoxide. If you have two of them, as we just see, we're going to use dioxide. If you have three of them, trioxide. 4, 5, like 4, then tetraoxide. Do you get
Okay,
it,
sir. Thank you. Yes, sir.
everyone?
Yes.
Yes, sir.
Yeah. Okay. So what I would ask you to do, just take the picture of the screen, or if you have the tape handout handy with you, keep it with you. We are just going to practice a couple of examples and then we're going to conclude our sessions today. Okay. So I'm going to stop sharing this. This one is pretty simple and pretty straightforward. For the first element, if you just have one of it, you do not use prefix. But if you have two or more, you use prefix. For the second element, you always use prefix and you always use suffix. So example would be CO, as we just talked about. Carbon, it's just one of it, so we do not use any prefix. Oxygen, it is second element. We always use prefix and always end that with IDE, monoxide. If I'm going to give you the example like CCl4, what do you guys think? C means
Carbon.
carbon, because we just have one of it. We don't use any prefix. So we're just going to call it carbon. Cl4, because we have 4 of them. What should be the prefix?
Tetra.
4 would be tetra. And this always end with IDE. What will we have? We have Cl. So what should be the name? Cl?
Chloride.
Tetrachloride.
Chloride. Great job, guys. Carbon tetrachloride. All right. If I give you the same name like this, Ci4, what should be the name of this compound?
Carbon tetraiodide.
Excellent, right? Carbon, we have 4 of them. So tetra is iodine, so iodide. So remember, for the second element, we always use prefix and we always use IDE as suffix. For the first element, if we just have one atom, we do not use prefix. But if we have 2 atoms, we do use prefix. For example, let me just give you. Now, if we have to name this, how we are going to name it? The first element.
Dinitrogen.
Right? Keep it simple. we have more than one of the first element. It means di. If it's two, then it's di. But again, we are going to name it as an element. So nitrogen, right? Di nitrogen. For the second element, we have four of them. So we're going to call it tetra. It's oxygen oxide, dinitrogen tetroxide, right? Actually, you just put it together, like when there is A and O, you just say tetroxide. Okay, my bad.
Okay, sir.
Do you understand this? Do you follow this?
Yes, sir.
If you have something like this, P3Cl5, how are you going to name the first one?
Triphosphorus.
Everybody get it? Because there are three, we have to use the prefix tri. Phosphorus, P is a phosphorus, so just name it as an element, phosphorus. For the second element, we have five of them. So we say five means
Penta.
Penta.
penta. And what do we have? Chlorine, so it should be chloride. All right, simple. So we use prefix for the first element if we have more than one atom. Then we name it as an element only. For the second element, we always use prefix and we always use suffix. Everybody understand this? Follow this?
Yes.
Yes, sir.
Yes, sir.
All right, let me just give you just one more, a couple of more example, just to make sure that everybody follow this. Look, at the moment, I'm just making this up just to make sure that you follow you understand this, okay? This molecule I'm just trying to making up. SF6. What do you guys think? What should be the name of the first one?
Sulfur
Sulfur.
heptafluoride.
Sulfur, that's right, because we just have one of it. We're not going to use any prefix. So sulfur. For 6, what do we call? Hexa, right? Of course, you will need practice and it will come naturally, okay? 6 means hexa. And F is fluoride.
Hexafluoride.
Okay, so we use prefix, we use suffix. For the second one, P3 and 3 and 8.
Triphosphorus.
Because we have 3 of them, now we're going to use the prefix tri. We're just going to name it as an element, phosphorus. 8 is
Octanitride.
right, like an octopus, right? Octanitride, IDE. Right? So all I'm going to do, I'm just going to rewrite those, right? 1 is mono, 2 we call di, 3 we call tri, 4 we call tetra, 5 we call penta, 6 we call hexa, 7 we call hepta, 8 we call octa, 9 we call nona, and 10 we call deca. All right, I'm gonna give you like 1 minute to copy this, or if you just want to take the picture, you can take the picture of this. So remember guys, we actually cover more than 50% of the syllabus for your exam 1. So I hope you guys all do really well in your first exam. You already have my email address during the entire semester. If you ever need any help, you can feel free, you should feel free to reach out to me. I am also the co-chair of the Science Study Center, which actually provide you the free tutoring. So if the students who already have taken these classes, are there, are available to help you guys, solve the homework problems or do some the lab, how to do the lab assignment, or any how to solve the pre-lab quiz, something like that. So the tutoring, free tutoring, I would say, is available for all of you guys. If you guys ever need any sort of help, you can reach out to me as well. Okay, so remember, I am here to help. If you guys ever need any help, feel free to reach out to me. I wish you all the luck, and I hope this workshop was helpful to you. Okay,
Thank you.
right.
Thank you, sir.
Thank you
Alright.
so much.
Thank you so much, sir.
Thank you, Professor.
Thank you, Professor.
Thank you, guys. You guys are awesome. I wish you all the luck. Remember, I'm gonna send out a feedback form. I need your feedback that how you, if you find this workshop helpful, please give me a feedback. I'm gonna share this with my department in order to implement such kind of workshop for all the other courses, not just the chemistry. If I get a good feedback, I can kind of convince the other faculty to do such kind of workshop, and it could be really helpful to all of you guys. Okay, so I'm gonna share a feedback form maybe later on today or tomorrow. So if you have time, please fill that out. It won't take more than like 5 minutes of your time. Okay, so I'll really appreciate if you can give me your feedback. And again, thank you so much everyone for attending this workshop. I hope it was helpful. I hope you guys all do extremely well. All of you guys get A in your classes. And yeah, have an awesome semester. Okay, thank you so much
Thank you.
for your attention.
You're
you.
welcome, sir. Thank you. Bye.
Thank you. Bye-bye.
Bye, Professor.
Thank you.
Bye.
Professor, I have one question.
Yes.
So, will you post this recording video on the YouTube so we can watch it anytime on the YouTube? Sometimes the Zoom videos cannot accept it.